Now we're going to configure the networking of the cluster. Azure gives you two options, two models for networking. One is the default Kubernetes model, and the other one is the container native interfaces. And for us to explain it, let's go back to the architecture. You can see here that each pod inside the node gets its own IP address, and the node here also will have its own IP address, which is different than this one. The basic and default networking model of Kubernetes is called KubeNet networking, where the node will get an IP address from the Azure Virtual Network subnet, and every pod here will get his IP address from a logically different IP address range. So these IP address ranges will not be visible for the external world. Then in this case, pods will reach the external world using Network Address Translation, or NAT. So the other networking model is called CNI, which is Cloud Native Interface. Sorry, it's called Container Native Interface. And in this case, let's just clear a bit all of this and have it completely new. So in this model, what you will have is that each pod inside your node will get his proper IP address, and this IP address can communicate to the external world. The pod can communicate using this IP address to the external world and at the same time receive information and traffic from the external world. But in this case, each IP address here has to be unique across your whole cluster, and it's part of your subnet. In case you're not that much familiar with Azure Virtual Networking, we will touch upon it in just a second, very high level. Let's go back to our networking and choose Advanced. Remember, Advanced again is the CNI model I just mentioned. It's the Container Native Interface, which gives an IP address to each pod inside your network. And here you'll be asked to create a virtual network. We don't have a virtual network, we did not create it again before. Then here you will see that you have the option to either create a new one, or the system here, Portal, will create automatically one for you. When I was speaking just before about the subnet, so in general, virtual network is just a private network in the cloud. Think about it just like the LAN network in your premises. It has a range, an IP range for the whole network, and it has inside this range, it is subdivided into subnetworks, or subnet for short. We're gonna leave everything as default, but it's important to know that here, well, I think this is a bit too much range, so we can just put it 16, and here we can leave it also default and put the address range at, so for example here, this is the complete subnet here, which consists of 65,000 addresses, and this is the unique address of your virtual network, and the subnet is subset of this. So I can choose to have, for example, a small subnet of 24, meaning that you will have, as mentioned here, 256 addresses for this subnet, which is part of this 65,000 addresses. This is very high level what is the virtual network is. Then you go back and you press OK. And here we have an error, which is good. It's good that we changed the default cluster to explain to you what is this. So the Kubernetes service address range, you understand that Kubernetes uses a master to orchestrate and manage the whole nodes, and for that he needs to run some services, and these services needs an IP address, and here is the range of the IP addresses that you define, and it tells you the address must not overlap with any subnet IP address range. This one is within the range of this one, so this is 10.0.0.016, and if you go here back to the virtual network, you'll see it's the same range, so it collide. You cannot have this. So what we will do is we can just change this 0 to 1. Sorry, we are here. So we change this 0 to 1. It should be okay. And also part of this is the DNS service. it has to be part of this range. So it's also, let's put 1 here. And I will explain what is this just here when we speak about the DNS name prefix. And finally, the Docker bridge address. Remember from before that the architecture here contains a Docker runtime. And this Docker might be accessed from the AKS cluster. And for that, it needs an IP address. And that's what you give here, an IP address range to access Docker from the AKS cluster. So here you have the DNS name prefix. This is a fully qualified domain name that you will use to connect to your Kubernetes API to manage your containers after creating the cluster. The load balancer here we leave it as is. Private cluster also leave it as is. Private cluster just allows the master to nodes communication via private link. So the master will never go to the internet to communicate back to the networks. We'll always communicate via a private internal link. For us, we don't care about it for now. We leave it disabled. And network policy. Network policy is something important in the communication between pods. So pods can communicate to the external world, but what if pods inside the same node or pods inside different nodes inside one cluster would like to communicate to each other? How can they do this? And if you go back here to the architecture, you can see that here you have pod and here you have pod. And what if these pods would like to communicate to each other? And here is the network policy. For now, we will not be doing inter-pod communication. We will leave it as none. And then we go to the integration part. For the integration, the only thing here we need to configure is the connection with the Azure Container Registry, which we created a couple of videos ago. You choose the name of it. And then finally the monitoring. We're going to speak later on the course about the monitoring, but for now we can use the Azure Monitor, which is a service in Azure, to communicate with the cluster. And for that we need to enable it here and choose our log analytic workspace. Don't worry about this, we're going to explain it later, but for now leave it as is. And finally review and create. It's doing the validation now. Once it's done, you press on create and you will be having your AKS cluster. Validation passed. We go back down and we press on create. It will take a couple of minutes to create, so we'll pause the video and come back once it's done. In case you receive an error during validation or your quota is not enough, the easiest way to solve it is to just choose 2 instead of 3, and then you review and then you validate. You can see here the validation passed, and go ahead and create your cluster.